Here's question 6 and 7 then. So in this question 6, an acid H2X is reacting with sodium hydroxide like this, and we've given the information here. We've got a mass that was used originally of the acid dissolved in water and made up to 250 cubic centimetres. Then a 25 cubic centimetre sample was taken and titrated with some sodium hydroxide. The first thing it says to do here is calculate the number of moles of sodium hydroxide in this volume and concentration. So this is again using this relationship here. Number of moles is concentration times volume, remembering to convert your volume into cubic decimeters by dividing by 1,000. You do that, you get 0.00326 moles. In part 2 there are two parts to this question. It says calculate the number of moles of H2X which reacted with the sodium hydroxide, and then use that answer to deduce the number of moles in the 1.92 gram sample. So the first bit's looking at the mole ratio in the 25 cubic centimetre sample. Because we have a 2 to 1 or 1 to 2 ratio between the acid and the sodium hydroxide, we've got to divide our answer in part 1 by 2, which gets us 0.00163 moles. And then to work out how to scale this up to what was in the 1.92 grams, you remember that we've taken only a 25 cubic centimetre sample from a much larger 250 cubic centimetre sample, so it's 10 times larger. So in 10 times the volume, there'll be 10 times the number of moles, which is 0.0163 moles. Then we have to calculate the relative molecular mass, and to do that we use this relationship here. Relative molecular mass is mass divided by moles. We know the mass is 1.92 grams, and we know the number of moles is 0.0163. Plug them in and you get 117.8. And then part B, it says this compound Y is shown to contain this percentage of carbon, this percentage of hydrogen, and this percentage of oxygen, and we know the MR of Y as well is 146. So first of all, what's meant by empirical formula? Again, you've just got to learn it. It's the simplest whole number ratio of atoms of each element in a compound. And then we're using the information to get the empirical formula for 2 marks and the molecular formula for a further 1 mark. To do the empirical formula, we look at the percentage composition, percentage of each element, divide by the relative atomic mass of each element to get the mole ratios, then divide by the smallest of these to get the nearest whole number ratio. In this case we've got fractions. When we do this, we've got 2 halves here, so we've got times everything by 2, which gives us 3 to 5 to 2. So the empirical formula is C3H5O2, and if you work out the MR of that empirical formula, it comes out to be 73. So to get the scale factor to the molecular formula, we need to use the relative molecular mass of 146. If you divide that by the 73, you get 2. So the scaling factor is 2, and therefore the molecular formula is twice the empirical formula, which gives us C6H10O4. And then on to question 7. This is a much more difficult question because it's less structured and you have to think for yourself exactly the stages you need to go through to get the answer. We've got the reaction of lead with nitric acid here, and it gives us, the information we have here is the mass of lead and the concentration of the acid. We need to work out the volume of the acid for complete reaction. So the first thing we need to do is work out the moles of lead. So to do that, we're using this relationship again. Number of moles is mass divided by the relative atomic mass of lead, which is, so we're taking the mass, we'll look this relative atomic mass of lead up on our periodic table and get 0.0393 moles. Then we need to work out how many moles of nitric acid we've used for a complete reaction, so we're using this 3 to 8 relationship, or 8 to 3 rather relationship. So we multiply the number of moles of lead by 8 divided by 3, 8 over 3, which gets us 0.105 moles. And then finally we can actually calculate our volume now, because we know the number of moles and we know the concentration of the nitric acid. So we use the relationship volume is number of moles divided by concentration. We plug the numbers in and we get 0.0524 cubic decimeters. And now we move on to 7b, which is again an ideal gas equation question. This time you've got to take care there with the units especially. We have to calculate the number of moles, so rearrange the equation, convert the units here. We've got 101,000 pascals, and we've got 638 cubic centimetres becomes 638 times 10 to the minus 6 cubic metres. Put these numbers into our rearranged equation, and we get 0.20260 moles. And then the final bit, first of all, balance this equation about the reaction, the thermal decomposition now of lead nitrate. It's to balance this you need 2 here, 2 here, 4 here, and 1 here, which isn't really necessary, so I'll put it in brackets. And then two questions here which require you to think a little. Suggest one reason why the yield is often less than expected, but there's a number of reasons you can use. Incomplete decomposition, side reactions or byproducts form, some NO2 escaping, not all of it reacts, similar to this idea, or the idea that the lead nitrate that we started with was not pure. You cannot have a mark for saying about a reversible reaction here because the question doesn't show an equilibrium sign. And then finally, suggest one reason why it's difficult to get a pure sample of nitrogen dioxide from this reaction. Well, if you look here, we've got two gases being formed which is difficult to separate. So that's what they're after there. It's the idea that this mixture of gases formed is difficult to separate. And that's it.